Okay, everyone, we'll continue. Uh, so, so then 1995 onwards, the internet became. So 1995 onwards, internet became public. So before it was just so before that it was just it was an exclusive network only for certain people. Only certain people were able to access the internet at that time. So then afterwards, after 1995, it was made in public. So more local networks. So still, if you take internet, it is just a collection of local networks that are interconnected all around the world. So that's the same thing. So it was more networks were able to, more machines were able to connect to the internet, and the number of devices connected increased. But still, it is not that popular. But so it's called Internet of Geeks. So geeks means only people who are interested, who are enthusiasts about science and technology. So only these people were using internet at that time. The main reason was it wasn't that useful for most people. Most people are not interested, are not concerned, interested or concerned with the what is going on in the background, what is going. So they want to do their thing. They have other interests, so they want to do something convenient with the internet. They want to make their life convenient through internet. So if but at that time there was the applications, number of applications were very limited. So for people it wasn't that useful. So that why most people wasn't using internet at that time. So only like certain people were using it. So that's why it's called Internet of Geeks. So only these people were using it. It wasn't useful for most people. Then the era of Internet of Masses. So in 1996 six itself, there are like so many companies already started, like Amazon already started in 1996. Now it is one of the biggest, could say it is the biggest internet company right now, in retail or in case of cloud services. They're actually, their clients are like all around the world, like even biggest corporations like Google are their client when it comes to cloud services. So they own like a big portion of internet. Their servers are working for so many of the biggest companies, and biggest applications are run through their servers. So that type of companies, so companies like Amazon were already established. So like if you take that single example itself, how internet became popular, it is obvious. If you take the single example of Amazon, Amazon started as a book delivery application. So the online book delivery application. So their initial idea was to replace the bookstores, actual physical bookstores. So we know that it is actually inconvenient for most people. It is not very convenient to go to a bookstore. They have a work week, and they want to relax on the weekends, and they want to buy a book, but they have to go somewhere, and they have to go to the bookstore. Either they have to go to a library and browse through the library and find their book, or they can go to a bookstore and browse there and they can find the book. So it will take time and effort to do that. Still, you have to pay the same amount for the book. But with the internet, with the website like Amazon, you can go through it. You can go through their index. You can search in their index, and you can find whatever book you want instantly. Like within a minute, you can find your book, the book you want, and then you can order the book. So within 1 or 2 days, you will get the book delivered at your doorstep. So that is very convenient compared to actually going to the real shop. So that is the one example, one small example of how useful internet was or still is. So even still at that time there wasn't that many Amazon like websites were available. So most people weren't using it, and also other factors are like PCs are very expensive, the hardware is very expensive, and internet connectivity is very expensive. So it's even if you pay so much money, still it won't be that fast, and things you can do are very limited. So that's only limited people were using it at that time. That's why it's called Internet of Geeks. Only interested people were using internet at that time. Then we know about IT boom, and all those things, like late 90s, 1999 and 2000s, early 2000s, the IT boom. So the city like Bangalore, in India, that became a major industrial city in India because of because of IT boom. And Bangalore is now like one of the world's biggest IT hubs. So it is like the San Francisco of India. Like all the most of the IT jobs are located there, and there are like so many electronics and so many companies are there. So this all happened, and a company like Wipro emerged as a result of this IT boom. So Wipro is now one of the biggest MNCs in the world. So in from 2000, because of the IT boom, the IT boom happened because the businessmen, people in general, they saw the usefulness of internet. Just with the Amazon example, we know how much convenient it is to use internet for one thing. So we can expand that to so many different areas, and so the life becomes much more easier through internet. So that was already established in late 90s. So that's why IT boom happened. So many businesses, so already existing businesses started using internet for their services, and so many new companies, new businesses were established fully based on internet itself. So all this happened during during late 90s and early 2000s. So that then 2000 to 2007, it is called the era of internet of masses. So more people started using it. More internet became actually public. So in 95 it was public already, but it wasn't exactly public because most people were using it. So in 2000s toward onwards, 2000 onwards, it became actually public, because so many different new things were implemented in internet. So internet became internet of masses. But still there are some problems, because if you PCs are expensive compared to the older times. PCs are not that expensive. PCs are common, but still they are expensive compared to today or any other time. Like they are expensive, kind of. Maybe compared to today, it was not that much expensive, but still the hardware was expensive, and that is not the most part. People can afford to buy. Most people can afford to buy a PC, but they cannot get a proper internet connection. They can get an internet connection, but it might be slow because it is a home connection. They can't pay that much amount every month, so the connection, the speed will be very low. Otherwise, they can get a connection like dial-up connection. So that is very slow. We can only do like limited things using that type of internet. So it is not very useful. So that gave rise to these places called internet cafes. So internet cafes became popular because of this reason, because of slow internet at home. So if you want to do something and you don't want to use internet throughout the day, like we do right now, but you just need to use it for certain purposes, like you want to apply for something, or you want to download something, or some certain thing you need to do, but for that single purpose you don't want to pay an expensive internet bill. So you can go to an internet cafe. So internet cafe means there will be multiple systems, 10 or 20 systems, or maybe more than that, and they'll have a very good high speed internet connection. They can afford that because they are a business. They can afford that. They can charge money from people on an hourly basis. They can charge money from people, and they can pay for their bills easily, and they can run it as a business. So that was happening at that time. So if you remember those times, you can like the internet cafes were very popular at that time, before the mobile phones, smartphones, or internet phones. Before internet phones and all that, people would go to internet cafes for all kind of things, like for browsing, for Google browsing, or watching videos in YouTube, or for exam applications or job applications, or for so many different purposes. people would go to internet cafes. Then the era of mobile internet. But here also in Internet of Masses, the number of connected devices increased. Again, increased. The number of devices connected to internet again increased because of popularity of internet. Then mobile internet. So mobile internet actually increased the number of internet users so much because mobiles are very affordable, and you don't need to get another thing about mobile is that you don't need to get a separate internet connection. If you have a SIM card, you can the network provider will act like an ISP, so they can so you can use the same SIM card to access the internet. So you have to pay additional charges for that with the talk time, whatever talk time you have. But still, it is much more affordable than compared to a home internet connection, a broadband internet connection. So that made internet much more popular because more people are able to use it, and more devices are connected to internet. Then 2012 beyond, Internet of Things. So that's what we are going to discuss, 2012 and beyond. So Internet of Things became popular because more devices are able to do tasks fully automatically. They don't need any human intervention, human instructions. They can do any task in real time without any instructions. So that's one of the reasons why Internet of Things exists today. So why internet? So for obvious reasons like anytime, anywhere, any person, any business, any device, any network. Then no one owns it. Like features of internet, some of the features of internet, no one owns it. It has no formal management. It was originally developed by Department of Defense, US Department of Defense. So this lack of centralization made it less vulnerable to wartime or terrorist attacks. So it is decentralized. So no one can shut down internet. No one can shut down internet at once. It is not possible because it is decentralized. It is spread all around the world. So attacking one place is not enough to shut down the internet. So then to access the internet, and existing network need to pay a small registration fee and agree to a certain standards based on TCP and IP. TCP/IP. So even in the earliest days of internet, the ARPANET, still it was run through. It was using the same TCP/IP suite as we use today, as the internet used today. So TCP basic building block of internet is TCP/IP. It is built on that. Then when it comes to history of Internet of Things, so in the term Internet of Things was first used by Kevin Ashton in 1999. So this Kevin Ashton was the person who first suggested the name Internet of Things. Then what is Internet of Things? So already I've explained that the idea of Internet of Things. Like it is any object, any device that is connected to internet, any that is able to execute some task without any human intervention. So it's the similar idea here. Internet of Things is the network of physical objects, devices, vehicles, buildings and other items embedded with electronics, softwares and sensors. Network connectivity enables these objects to collect and exchange data. So the physical objects like vehicles or buildings, these are not electronic devices. They don't have any softwares. So if you take a vehicle, it is a purely mechanical device, a purely mechanical machine. So it needs some embedded electronic device to access the internet, to run all the softwares. So the softwares then in turn will utilize hardware to connect to the network, and using the network that the object can collect and exchange data. So there are like so many examples today. Like if you take smart cars, so for example like cars like Tesla cars. So they're like They're like a laptop that we use, like a Windows laptop. Automatically, Windows laptop on a monthly basis, or whenever there is a update, or your phone itself, Android phone itself, whenever there is an update, automatically it will download. If you give consent for automatic updates, then it will automatically download the update, and it will install it. You wouldn't even know that the system is updated. So because of that update, your system will get more efficient. They'll rectify so many bugs, and the system might get faster. So if your hardware is slow, then no update will make it faster. But still, if you have a good computer, then the hardware is good, then you'll get, the system will become more faster. So the same thing can be said about a Tesla car. It is also connected to say similar type of network, and it can, without the driver, without the owner knowing, the car can download updates, monthly updates, and they can upgrade the system. They can upgrade the whole system. As a result of the upgrade, the car performance may improve. The car performance may improve. That means maybe the car will get faster. So the actual mechanical properties will improve. So that is one best example of Internet of Things. The car is automated, fully automated, and it is connected to the internet. And also, like in so many cases, the people from a remote location, from the Tesla center, like service center, they can access the car for so many purposes. Like if you accidentally lock your child inside your car, and you don't have the keys inside the car, and you accidentally lock the child inside the car. In that scenario, you can contact them, and they can unlock the car. Or so many other cases, you can use that type of services. So in all these cases, the actual vehicle is connected to a network. Because of that, it can be considered an Internet of Things application. So then it involves sensors and microcontrollers, processors, microprocessors, SoCs, different type of hardwares. The main idea is to collect and exchange data. So anywhere, anytime, and machine-to-machine communication. So automation is a very important factor in emergence of Internet of Things. Automation and machine-to-machine communication. So like mostly machine-to-machine communication means there is a human, in the most conventional sense. There is a human controlling one machine, and another machine is communicating with another machine, and at the receiver end, another human controlling the receiving machine. But in case of Internet of Things, there is no humans involved. It's just a machine-to-machine communication. Both machines are fully automated. Then the properties, like where we can use Internet of Things. So like the Internet itself, the possibilities of Internet of Things is limitless. So if we take Internet, if we know that Internet is used in almost every areas of life in today, these days it is used in every areas of life, every walks of life. So it is still, there is no limit to it. You can every day you can find a new way to use Internet. So it is such a a new thing, could be such an abstract thing, because so we can find a new thing every day. So that it is a limitless thing. What we can do with Internet. So the same way Internet of Things can be considered the same way. It is the applications of Internet of Things can be anything. So this is one example on your campus. So in a school campus. So on a campus means could be a college campus or a school campus. So this is one example, a smart Internet of Things school. So Internet of Things established in a school. So these are like things that we can implement in that school environment. So personalized learning with adaptive textbooks and digital classrooms, whiteboards and displays, video records for lectures and lecture capture, international collaboration and social exchange. So for example, international collaboration, you can use virtual classes So actual people doesn't have to go there. Like for normal social exchange programs, a person has to go there. Student has to go there, has to go to the institutes wherever whether it is a college or a school. Actual student have to go there, and they have to stay there for like a year or so. But in case with the internet and internet of things, we can easily make a virtual class where there are like actual students sitting in the class. Also, there are students who are accessing the class from a remote location. So this is also very helpful for like people who are traveling all around the world for any type of purpose. If they have children, they don't have to miss their school. They can every day they can attend their school online. So then online testing and student devices, e-textbooks, notebooks, tablets, smartphones, sensors on trash receptacles, robot cleaning, and file program storage in cloud-based. Then network application analytics, monitor devices and network behavior, robotics for STEM and remote presence. Then surveillance security systems. We can automate the security systems and using like AI and deep learning. With the Internet of Things, you can completely automate surveillance systems. There is no need for anyone to sit and monitor the video feed. It can be fed to a deep learning program. It can easily identify whatever we have trained, like any weapons or any unknown people or any like if night times there are people there or any type of violence happening. So many things can be detected. So we can make the whole surveillance system fully automated. Then augmented and virtual reality based applications. Then complete coverage with high performance Wi-Fi, wearable for athletics and attendance tracking. So athletics and attendance tracking, you can have both. So for in case of athletes they can wear devices that will monitor their different, like we have smartwatches these days. They can count heartbeats and things like that. They can take your BPM, beats per minute, BPM and all that. But you can have a much more high-end device that will track so many different parameters of an athlete. Based on that, we can the trainers can assess the performance of each athlete every day, whether they're track and field or any other type of sports person. And attendance system can be implemented using different type of identification systems. We can use fingerprint or you can use face recognition, or you can use RFID cards, or you can use NFC. So NFC is in all of these, NFC is a better choice, because a fingerprint or face recognition or a case of RFID, the student has to go somewhere and they have to either swipe it, or they have to put their finger, or they have to show their face in the camera. So the whole process has to be done in only that place. So it is not exactly automated in that sense. It is automated, the background process is automated, but the person has to go there and do it. But if the attendance is already registered as you enter the class, if you are inside the class, then that means the whole automated system, attendance system can sense your presence. Based on that, it can note that you are present in the class, or you're absent in the class. You're absent at that time. So this can be done through NFCs, near field communications. So NFCs are like we are already using it in so many different places, like fast tags used in automatic toll collection systems. Like while a car is arriving, without stopping, without paying, they can just go. The payment will be done automatically. While the car is in like a 10-meter range or 5-meter range, automatically the toll booth will identify the car and recognize the user, and it will take the amount from the user account. Or they can leave the they can go through the toll gate without even stopping or slowing down. So that is one thing in using NFC. So one application that already exists. So this similar type of NFC devices can be used for attendance systems. So attendance systems and also they can be used for like sensor buses and verifying student passengers. So if for a passenger like lower standard students, like students up to age 9 or 8, they can be the parents can track them in real time. They'll know whenever the student enters the class. They'll know this whenever the student enters the bus, whenever the student leaves the bus. So they can easily track them and they can verify where the children are. So using that type of NFC devices. Then supply and inventory tracking and sensor auto reorder and market space and 3D printers, laser trimmers, Internet of Things, HVAC, monitor and display of air quality throughout the school, sensors in parking lot and driveways. So these are not all the different applications that we can use. Still, we can find in this single scenario like Internet of Things in school, you can find more applications, much more applications. So in the single scenario itself, the number of applications are limitless. So in Internet of Things, next we'll see the connected devices. So one of the factors that gave rise to Internet is automation. Factor of the automation. Devices are much more smarter and they can execute tasks without humans. So that is one of the factors. Another factor is connected devices. Connected devices and automation are interconnected in a way, but we can analyze them both as two different factors that gave emergence to Internet of Things. So current status and future prospect of IoT. So IoT depends so much on the number of devices connected to the internet. So here this is the chart wise representation of world population versus number of connected devices, and here you can see the ratio between connected devices and world population, connected devices by world population. So in 2003, you can see the internet number of devices connected to the internet was 500 million and the world population was 6.3 billion. And then just in seven years, you can see the number of the world population increased just 0.5 billion or 500 million, but here it has increased to, connected devices has increased to 12.5 billion in just 7 years. And that means that for every single person there is almost 2 devices connected to internet, 1.84, like almost 2 devices connected to internet. And if you take today, like even 2022 itself, there are like so many places in the world that where it is not possible to access the internet, where there is no internet connectivity. Still, people live, or like even if you take places where there is internet connectivity, but there are like people who cannot afford the services. So there are like so many people who cannot access. But here you can see that like in 2010 itself, there is like for every person there is 2 devices connected. So even if all the people are using a single device, still it won't be enough to cover all these connected devices. Then in just 5 years, again it increased to 25 billion. World population is only 7.2 billion. So the 2015, for every person there is 3.47 devices connected. Then in 5 years, 3.47 increased to 6.58. So 50 billion devices, and the world population is 7.6 billion. World population 7.6 billion. So here you can see the number of devices is a major factor, and Internet of Things is a major factor in increasing number of devices. And then hype cycle of Internet of Things in a hype cycle of different technologies, and Internet of Things comes here. So then layered representation of internet of, we can represent internet of things in different layers. Business value, big data, cloud, fog, all these can be different layers of internet. And in the first case, people and process is a one layer, layer 7. So people and process, so whatever we make, whatever technologies are science or whatever development that is being made, there is always a user, end user is a human. So same as that here also in internet of things, people and process. People and process is the last link. And then applications. So whatever custom applications built using the thing data. So custom applications, so many internet applications you can use on it, like whether it is a system application or mobile application. If you have done your own small projects, you'll know that there are like so many Play Store applications are there. You can use these to implement different Internet of Things systems. Then data analysis. So data analysis means machine learning, data mining, and reporting. All these comes under data analysis. So the data analysis means like machine learning or data science. So machine learning, if you take machine learning itself, you can train a system by giving input data. By giving a data set, you can train a system. So then the whole idea of machine learning or data science or deep learning, all these, whatever data given, the system will try to find a pattern. So find a common pattern in all these data. Then it will train based on that pattern. So its main objective will be to find this pattern in this data. So whatever data we given, it could be numerical data, it could be images. So if you take the image example in a deep learning program, if you want to recognize aeroplanes, we can feed so aeroplanes may look different from each other. Like a commercial aeroplane will look so much different from a fighter jet or any kind of or a commercial aeroplane may look different from a cargo plane. It may be much more bigger, and it will be different from an amphibious plane. So these are all like different type of aircrafts, but they all comes under the same class, aeroplane. So if you want to train the system for aeroplane, then you have to feed all these things, all these different images to you need to train the model with all these input images. So even if the fighter jet and the commercial plane look different, but still they have so much similarity. They use the same basic principle. Maybe the thrust is different, but the basic principle is the same. The flying principle is the same. So they have to look similar. They all have tails, wings, and the tip will look the same. So the overall shape will be the same. So these are like the common patterns. So if you give like a 10,000 different aeroplane images, the system will try to find a common pattern. What is a common thing between all these different images? So based on that common factor, it will generate a model, and then in that model, it will using that model we can recognize similar objects. So if the pattern and the input image matches, then that is a recognition, that's a detection. So that is same with the machine learning programs, where you can give like input data, and the data the thing will be analyzing the pattern, and then based on the input data it will make predictions. So that is data analysis. So it can be used in so many areas. You can find so many applications for that. Then data ingestion. So data ingestion comes under like big data, harvest, storage of thing data. All these comes under data ingestion. So if data ingestion means like using data mining, you can analyze like different data, and based on that you can give, like for example, one application is advertisement. So these days we'll get personalized advertisements in all these applications, like internet applications. You will get personalized advertisement. So So advertisement for me might be different from an advertisement for my friend. He's just sitting near me, but because of his interests are different, my interests are different. So based on our interest and our need, we'll get different information. So this can be decided through data mining and big data. So data ingestion means like inputting the data that is needed. So it also can be seen as part of like a bigger AI. Then global infrastructure, different type of infrastructures like cloud infrastructure, public, private, hybrid, and managed. Different type of cloud infrastructures like Google, AWS, ThinkSpeak, all these different type of cloud infrastructures. Then connectivity and edge computing, so communication protocols, networks, machine-to-machine communication, Wi-Fi, telecom, hardware kits, all these comes under connectivity and edge computing. So that is already existing thing, then we are utilizing that for Internet of Things. So most of the things that are done, that are implemented in Internet of Things already exist. So that is being used for Internet of Things. But there are like some new internet application layer protocols in Internet that are purely used by Internet of Things applications. Like you can say like COAP or MQTT. These are like mostly used for Internet of Things applications. Then the last layer is devices, sensors, controllers, etc. So we'll be going into that in more detail. So how to communicate. So to communicate, first you need to sense the area, whatever place you are in. For example, if you need to make an application where you have an industrial area and you need to analyze the air quality in that area, analyze air quality and see if it is apt for humans to be there for a long time. So to do that, you can collect the data using equipments. You can read the data manually, and then you can analyze that you can analyze that manually and come to assumptions. But otherwise, we can make the whole process automated. We have the capability to make the whole process automated these days. So you can use sensors, different type of sensors that can measure different elements in air, like example CO, carbon monoxide, and other type of gases. So we can measure using gas sensors. You can measure content of air, and then that data can be logged. So sensor is connected to a controller or an SoC or a single board computer, and the data is collected from the sensors using the controller, and the controller is connected to the internet through a Wi-Fi module. So then so it is connected to a particular cloud, like for example AWS cloud. It is connected to AWS, to an account. So whatever data that is being collected, it is directly uploaded to the cloud, and in cloud it is arranged in a dataset form, and then in AWS itself you can run a machine learning program that can take this data as real-time input data, and it can make predictions based on that. So predictions like if people breathe this for like a month or 2 months or 6 months, what will happen to them in future. So what type of health issues they can anticipate in the future, or how long they can go on breathing this without causing any major problems. So that is very helpful in so many ways. So in all those things, the starting point is a sensor. So we need sensors to make things more smarter. The sensor. So here this is just a definition of a sensor. A sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. So it can be read by an observer or an instrument. So there is a basic idea of sensor is to convert a physical parameter to an electrical signal. So each sensor has a unique mechanism that it uses to convert the convert the physical parameter to electrical signal. So like you can take so many different examples. Like if we take one simple example, if we take one simple example like temperature sensor, we can say like LM35. LM35 is one of the most basic temperature sensors. Probably the cheapest temperature sensor. If you are doing some academic projects, you can use LM35 temperature sensor for temperature sensing. And it uses, if you search LM35 online, you will see like a image of a diode, a transistor, image of a transistor. So LM35 is basically it's like a BJT, like a transistor, but it is not exactly a transistor. It is different from a transistor. It uses the property of semiconductors. The semiconductors are susceptible to external temperature. So it uses that property of semiconductor to sense temperature. So that is the idea of semiconductor itself. Like it'll like in absolute zero, it will become totally insulated, and as the temperature increases, the conductivity will increase, and there is a breaking point. So these are all. So most of the electronic devices are shielded from these effects. But temperature sensor LM35 is specifically designed for that purpose, to be more sensitive to temperature. So as the temperature, the conductivity will change. Based on the conductivity change, the current flow, the voltage output will increase or decrease. Based on that voltage level, we can say this is the temperature, current temperature. We can use conversion equations and you can say. So that is one mechanism in which it uses the property of semiconductors to measure the temperature. Then another one mechanism, if you say, we can say like accelerometer sensors. Accelerometer sensor comes under the class of MEM sensors. So accelerometer sensor, it actually measures the orientation. So all of your mobile phones, all of your smartphones have accelerometer sensors inbuilt in it. So the purpose of that is to measure the orientation of your phone, whether it is horizontal or vertical, or how you're holding it. So even if you play like a video game, you can just tilt your phone. You're playing like a game, like some bike game or car game. You can tilt your phone, and as you tilt your phone, the virtual object in the game will go left and right. So that is based on the accelerometer, gyroscope, magnetometer. There is a whole set of MEM sensors inbuilt in your phone. And it is also used for other practical applications like Google Map. Google Map uses all these sensors too. It uses GPS to locate you, then to check your orientation. It uses all these sensors, whether you're going straight or not. That can be sensed through these sensors. So in case of accelerometer sensor, it uses the principle of capacitance, principle of capacitors to measure the orientation. So in capacitors, we know that with the distance, the capacitance will increase and decrease. So the capacitor is basically two electrodes. In between two electrodes, there is an insulation. There is an insulator. So depending on the distance between the electrodes, the capacitance will change. So in accelerometer sensor, there is a fixed part, there is a fixed plate, and there is a suspended plate. The suspended plate is suspended through a spring, a mechanical spring, and as we move the sensor left and right, the moving plate will move towards or move away from the fixed plate. So there is air in between. So the air is the insulator. So there is air in between. So that means the conductivity will change based on whether it is going towards or away from the fixed plate. The conductivity will increase and decrease. So based on that, the voltage will vary. Based on the voltage, we can measure. We can see whether the sensor is going to the left side or right side or forward or backward. So that is we can measure the acceleration in different directions. So then you can use these are like some of examples of sensors, and then you can use any one of these devices to make your own Internet of Things system. So this is two examples. This is an Arduino Uno board and Raspberry Pi 3. So Arduino Uno board, it is useful in case of if you are making a prototype, or you want to try something, then you can use Arduino Uno board. But if you want to learn embedded systems in more depth, then you have to go with some basic some other type of microcontrollers. So you can, if you want to start from a basic level, you can study 8051. You may be already studying that in your college. 8051, or you can more advanced microcontrollers like ARM7, or you can use different type of PIC microcontrollers or AVR microcontrollers, or you can go with the TMS boards, TA boards, or MSB boards, or you can use ARM Cortex boards. If you want to go to more advanced, you can use ARM Cortex boards, different type of ARM Cortex boards like LPC boards or MSB boards. Or you can go with the so these are all microcontroller boards, or you can go with the single board computers. So single board, there are like so many options to these days. Like single board computers are very popular in field of embedded systems these days, because we can combine so many different applications in one system, in so many different technologies in one system, in one single application. We can use deep learning, we can use a simple basic embedded system like robotics. You can combine deep learning and robotics and make an intelligent robot. So in all these cases, it will be much better to use a single board computer. So single board computer is it is an embedded computer, so it has all the peripherals that an embedded microcontroller has, but it won't be exactly real time like a microcontroller. Microcontroller is specifically for one task. So this is whether it is even if it is a single board computer is an embedded computer, even if it does all the peripherals, still it is a computer. It's a general purpose computer. So you can use a single board computer like this. Raspberry Pi is one of the most basic example, or you can use Jetson boards from NVIDIA, or Edison boards. So you can use any of these. So there are like so many options available these days. So you can implement a fully automated Internet of Things system using any one of these tools. So thank you guys. That's it. We have to end the class, end the session here. So thank you for listening. So I hope it was helpful for you. So you can use this as an introduction to Internet of Things, and you can try your own on your own. So like there are like so many resources available online. You can use our own platform, Pantechelearning, for that. We can apply for internships, online internships, and you can attend class every day, and you can improve your knowledge. Otherwise, you can try yourself. So you can try yourself, and whenever you have a problem, you can access some information other than yourself. Right? Okay, thank you guys. We have to find out the